Mm.
Yeah, that is okay, sir. It's the end of
Yeah,
the
yeah.
session is okay. But the
Okay.
problem is,
Uh,
see, in the morning I got disconnected. Then I
okay.
again connect from my mobile phone.
Okay.
So I cannot see the old what you say messages.
Old means we given before 10-15 minutes only.
Yeah,
At the
that
end
is
of
what.
session
So
only.
if I now, if right now, if I disconnect and connect again,
Okay.
okay, then I can't. I can see only the messages from this point onwards.
Okay.
So the
Yes, yes.
old messages,
I know that. So
yeah,
morning you join, na?
yes,
But not fill attendance.
no.
So you can fill now.
Okay, thank you very
Mm.
much. Thank you very much.
Next session is on Introduction to Data Sciences by Mohammad Suhail. Mohammad Suhail. Um, is a technical manager in artificial intelligence in Standard Chartered Global Business Private Limited, Bangalore. Soon he will join so that we will start the session 3. All of you please mute your mics. Morning sessions also we observed so much disturbances. So all of you please mute your mic and you can unmute at the end of the program only. All the questions you can ask at the end of the program only. Okay. Uh, so in this Google Meet, there is a no provision to control all the participants in a single click. So all are teachers so that you know the problem so that you can mute your mics or else session will close in the middle again disturbance will come, continuity will go. So please cooperate, please mute your mics.
Kumar sir, Suhail already there.
Sir Suhail sir,
Hello.
hello, sir joined na?
Yes, yes,
Yes.
yes.
Yes sir, yeah sir. Good afternoon and welcome to the session 3.
Very good afternoon.
Yeah. Madam Aditya, madam, you can start.
Welcome back, everyone. We are about to begin the second session of the FDP, Introduction to Data Sciences by Dr. Mohammad Suhail. Dr. Mohammad Suhail is working as a technical manager at Standard Chartered Global Business Services Private Limited, Bangalore. He has obtained his PhD in computer science from University of Mysore. His research and development interests include artificial intelligence, machine learning, deep learning, computer vision, and natural language processing. He has more than 20 research articles published in various national and international journals and conferences, and he has got an H index of 5. He has been actively involved in academic activities and due to his passion towards teaching and research, and he also enjoys delivering the technical lectures and giving hands-on training on the applications of artificial intelligence. He has served as an assistant professor of computer science for government for the first grade college, Tumkur University. So we welcome you, sir, for the for delivering the speech for this FTP.
Thank you so much, madam.
Yes, sir. Start sharing.
Yes, madam. Sir, can you hear me?
Yeah. Audible, clear.
Yeah, okay. So I've shared screen. Can you see the slides?
Yes, sir.
Uh,
Start.
Dr. Suhail, I'm
Has
feeling a
come up?
voice break.
Voice break. Okay. How about now?
Whether
It's okay, sir. You can
it's okay.
share
It's
your.
okay, fine.
Let me reshare my presentation also.
Yes, sir. Yes.
Let me know when it populates.
Yes, sir. It is coming.
Okay. So, uh, dear participants, a very good afternoon to you all. And
It's visible.
yeah, okay. So, um, I'm fortunate enough to be part of this FDP program and share some of the ideas and overview of the data science. And so I wish this session be a more interactive one. So if it is difficult to be interactive, you can just pose any queries or any interactions or anything that comes to your mind on the chat window. So we'll definitely address to that. So with that, let me just um, proceed with the outline of my presentation on data science today. So I'll be talking on the importance of data and big data and challenges that it poses, and then how data science is used, and what exactly is data science, and why we have to learn, and what all things we can do with the data science, and what is the role of data scientist. Then the different concentrations, I mean the focus areas of data science, and, and different applications as well. Okay. So yeah, we all know why we need data science. Maybe we say we know, but we do not know why exactly and what exactly is data science. But we should understand first data. Then only the science comes first, because we are trying to apply science on the data. So what is this data that we're talking about, right? So we have abundant data around us, okay? But when we speak about uh, the data science, we talk about, or we worry only about those data which is in digital form. Okay, so when you think of a data which is in digital form, I think you might get lots of sources or lots of um, thoughts in your mind that, okay, this is also their data, this is also digital data. Okay, so I've just tried to put different sources of data, different types of data that is coming to be in a digital form, and which we can explore later. So the lots of data is being collected, and we are warehousing it, means we are storing it. So some of the obvious and important types of data are as follows. As you can see, it is web data, right? We are very well connected to the internet now, as you all know. So any website that you try to browse, or that you try to use for your maybe personal use or official use, okay, for learning or for everything that you use, so the data will be generated, or you will see some data from the websites, or website maybe generate your data as well. Okay, say a simple example for web data is e-commerce data, where you will see a lot of e-commerce websites, and data on the e-commerce sites is one side, and on the other side, the data of the customers who are using those e-commerce sites. That's an abundant data, some for somebody to, I mean, study, analyze, and interpret, then make some useful decisions based on that. Okay, so coming to the the fintechs, so financial transactions, the credit and debit transactions that you make. Okay, I mean, you use your credit cards. So in what all ways you're using your credit cards, in what all aspects you're making use of your credit card. So that shows what you are, right? So that come to the point. So this is also again a data. And online trading and purchasing, social network. Social network is a very huge data. So as you might have experienced, because if you just take an example of Facebook, so the there are billions of users on Facebook. Okay, so there is um, very huge data on such social networking sites. Okay, so which is of very high value, but that's not directly available. So hope you agree with me. So yeah, so we now understood data is all around us. So if you just try to imagine the size, the hugeness of the data, though these are not the very recent numbers, it just gives you the flavor of how huge the data could be today. Okay. Just for instance, Google processes around 20 petabytes of data a day. It was a survey, I mean, it was an estimation that was made during 2008. So just imagine now, after 12 years, how much data Google could be processing now. So it is definitely 100 or more than the what 20 petabytes is shown here, right? And for example, Facebook has around 60 terabytes of daily logs. So it is just a log. I mean, any transaction that is made on Facebook, transaction in the sense, any communication could be a message, could be which from which server what message has come for to which other server. So these system logs. So the log itself is around 60 terabytes per day. And the example could be eBay has around 6.5 petabytes of user data plus 50 terabytes of data per day. So just try to imagine the hugeness of this data. Um, so that's about generally the web data. Or if you think of some other data that we generate, the genomes project, the 1000 genomes project, which was a project taken, it has around 200 terabytes of data. I mean, you can just see that our whole world is filled with data, that too in digital form. It's very difficult for somebody to see. I mean, just to scan the data once, this huge data will require years together. So, so you have, I mean, imagined the hugeness of data. Now you know where is the data coming from, what all data we have. So this hugeness of this data makes it a big data problem. I mean, big data is not always only the hugeness of the data. Big data carries certain other properties as well. So big data is any data that is expensive to manage. So hope you agree. So these terabytes and petabytes of data that we just saw now from various sources, do you think it is easy to manage by someone? No. You have to spend millions and billions to just manage. I mean, keep them in a best storage. And very important is the customer's reliability and this data that is being stored by the organization. So organizations spend a lot on managing the data, and then what do they get by managing your data, right? So that's where the problem of data science comes into picture, and that's where we are trying to extract value from these huge, expensively manageable data. What could be done with this data, right? So as you all might be aware of these different properties of big data, so we call it as 4V's of big data. It is volume. Yes, I think you have already just imagined how huge it could be. And the velocity is the second property or the attribute of big data. That is the latency of data processing relative to the growing demand for the interactivity. I mean, here we talk about how frequently you're getting this data. Is it real time? Is it offline data, or is it near to real time? So that talks about the velocity with which the data is coming. And variety, of course, you definitely agree with me that it's not a single type of data, right? You got data of multiple formats. and data is coming from multiple sources, and the data is not carrying a single structure. The structure of data is also different. So you got variety in this big data. And the the new V of the big data is veracity. So veracity is a very important attribute in big data. That is where you worry about, do have so much of data with me? Can I mean, depend on this data? Is this data very clean? Is this data speaking only truth? Are there any biases in this data? Are there any noise in this data? Any abnormality in this data? So you cannot directly take all data coming to you and just think that all data that has come is really good. I mean, it is having some value in it. There may be lots of data within the data that you have that is carrying no value, but it might also be misleading you in some way when you try to make some sense of the data that you have with you, right? So that's the veracity problem, and it is an attribute of big data that's very common in whatever data that you try to work on. So I'm just trying to give you some, so imagination come experience about the data and its abundance and the properties and the challenges that it is coming with, right? Hope, so I think it's clear to you all now. Probably, yeah. So this will give you a better idea about the different properties. So if you see on one side, it is talking about the data variety. You could have different types of data like tables, reports, database data, photo. I mean the images, web data, videos data, audio data, CMS, marketing automation, SMS, social tech. So you just, I mean, it's just we have named it a few here. If you try to list down, there are thousands of different types of data that is available. And when you talk about the velocity, as I said, is it in coming in batches, or is it periodically coming to you, or it's near real time, or it is real time? Okay. And data volume, of course, you all know this. So the volume, definitely we have moved very far from petabytes now. So just try to imagine how much data we have and what nature of data is present with us. Excuse me. Yeah. So yeah, I've just tried listing down some of the types of data we have into different categories. So relational data. So you all know relational data means the data that is coming in a tabular format where you have the you can bring up the database concepts for entities and their relations. So it could be tables, transactions, and legacy data that you have collected and created in a systematic manner. Or it could be a text data, probably from web, which is very unstructured in nature, right? Unstructured because, I mean, unstructured for the machines, from the machine's perspective. It could be very well structured for you when you visit a website. The website content for you is really very well structured, the different information, and for you to browse through and get to the point where you are trying to focus on. So that is very well structured for somebody who is looking through or browsing through. But when you try to process it automatically through machines, it is a very unstructured data. Well, I mean, probably you'll be talking more about text data in your upcoming sessions. And some of the data could be semi-structured. For example, XML, it is not a completely unstructured data, it is semi-structured because you can parse out the data by using the different XML, the attributes that are present inside the data. So probably you can reach out to some parts of the data directly without much processing. I mean, without worrying about how to process it, but that is still unstructured, but it is partially unstructured. And some other type of data is graph data. I mean, you can just imagine the social network data as well here. So the social network of your friends, for example, your own network, if you imagine you have your own friends and those friends have friends again. So if you try to connect all these people who are on social network, that'll end up with a graph data. Or it could be, so for example, if you just take the uh, Google Maps and connect different locations, so you'll get the graph again. So graph data is, I mean, another form of data that you, get from other source of data. So social network, semantic web, Streaming data is also very important. Streaming means it is coming with respect to time. You are receiving the data in the time series nature. And images and videos, I mean, you just imagine how many images are there on the web and how many videos are there on the web. Your own, I mean, forget about others' images and videos, your own images and videos that you have uploaded anywhere on the web. Maybe let it be social media, let it be YouTube, let it be anywhere on the web, but the data is there. Can you afford to scan the data at least once? That's a very challenging question. But yeah, so you may ask me, yes, we do have all this data, and there are systems which are managing this data, and some of the data we are consuming, some of the data they are consuming from us, from our uh, browsing or from our usage of the web, maybe, or from usage of some other system on the internet. They could be gathering our data and they are storing it. But what to do with all these data? That's a very important thing. That's where we are trying to focus on. Some of the obvious, I mean, at the higher level abstraction, I just tell you that you can do aggregation and apply some statistics on such data, right? Aggregation means try to group the data, see what all grouping is possible, and come out with some combined decision of each group, and think of studying some statistics on top of such aggregation. So that's just possible on the data warehouse, on the data that you have collected. Then indexing, searching, and querying. So indexing means you properly organize your data. It's not just that you collect it and dump it into your file system. No, if you have just dumped the data into your file system, it's very hard for you to manage it. Forget about discovering something from it. Just to manage that dumped data, it is very difficult. So one way is you have to sort it out. I mean, you have to properly organize it. That's where the indexing things come into picture. So you index it. So that indexing will be helpful for you later going forward for some other activities like searching. You want to get to know some particular information from the data warehouse that you have. Unless you have organized the data properly, how could you reach to that person's data? So searching, I mean, it is when you call about searching, you have many ways. You could have organized it in a very best way in a tabular format into a database. You can just do some querying over that to get to the data that you are interested in, or it could be unqueryable. I mean, you cannot pass queries in some structured way like SQL to a data that is not stored in a tabular structure or in a relational database. So that's where the challenge comes again. So what type of searching do you want to do? Here, probably you could do keyword-based search as you do on Google search, for example. So you just do some keyword, you just input some keywords, and you want Google search engine to get back some of the very useful links or sources or the websites which are very much useful or which are relevant to your keywords. So it is a very huge problem that is still unsolved, but it is I mean, it's far better than what it was earlier. So there are a lot of trending techniques and algorithms that are being used today to do this keyword-based search. That to personalized. I mean, customized search engines are available now. Looking at how you search and probably from which part of the world you are, the results that are retrieved to you will be different, right? Then the pattern matching. Pattern matching could be as simple as that. I'm just looking for some um, entry or some keyword or some particular field in a very big document. Okay, and that field generally carries some pattern. I mean, if you want to look for a person's name inside a paragraph, how could you identify a person's name inside a paragraph? So that carries, I mean, if you read out the paragraph, you will come to know it is a person's name. Just not by knowing that the word that you're fetching is a person's name, it's also because, for example, you are reading some say Spanish paragraph where you do not have any idea about what name could be there. So it's a Spanish name, for example, but the paragraph is written in English. So you try to read that English paragraph without knowing that this word is a name. You can still decide that is, if there is name in this paragraph, that should be this keyword. How do you say that? You will try to identify the pattern or some I'll just boil down it to simple terms like grammatical structure of the paragraph, which gives you an idea of which word of this paragraph is a name, person name, if it is there, right? So such pattern matching, I don't want it to be done by myself, but I should have some machine, some algorithm, intelligent algorithm, which is capable of doing such pattern matching and getting me the names in the paragraph, right? So a simple example, probably you can just map it to any of the data that you may be handling or you are thinking of, and see what all things can be done and what all things will carry certain patterns that you can identify and fetch, but you want something like an algorithm to do that, right? So such tasks we can do with this data. And knowledge discovery, okay, this is ultimate that we want to do with the big data or whatever size of data that's with us. We want to do knowledge discovery for what? Um, each of the person who does the knowledge discovery will have such something in mind. Probably I may be an organization like a e-commerce organization. I just want to understand the customers, their behavior on my e-commerce site, and want to see which customer wants what and what he'll be focusing, and what should be given to him, what should be recommended to him when he comes back later, right? Such knowledge discovery is needed, which can be done through the statistical modeling and data mining, or you can include machine learning as well. Okay, so that's the sense of what all can be done on the data. But if the data was very small, very easily manageable, okay, and static in nature, you could have done it very easily by yourself using simple rule-based engines. But the data is abundant with it is not static, it's a dynamic data coming in mostly sometimes real time, and it is huge, and there is a lot of noise. You cannot rely on the data directly, so that are posing the challenges in designing such systems. Okay, so let's try to combine big data and data science together and see the potential, I mean, problems and potential things that can be done. So data scientist or data science carries sexiest jobs. I mean, very um, fascinating jobs presently. Okay, it was said then 10 years ago, but today it is true that data scientist or data science are, there are many names that are given. Okay, but though strictly speaking, there are differences between what each person does. But collectively, you can think of all of them as similar, though not same, right? So statisticians is, I don't think that is true now. Not only statisticians, it is mixture of statisticians and engineers together, and the scientists, right? So the US will need around 140,000 to 190,000 predictive analysts and 1.5 million managers. I mean, the analyst managers by 2018. This was estimated in 2011. Okay, so just imagine if it is 2018's prediction, how what could be the requirement now. So anywhere you see there are courses on data science, there are degrees, there are PG diploma courses, there are online degrees on data science or AI, machine learning. So that shows the importance of this field and the job that is there on the job market for these fields, and that is also possible only when some research is done on such areas, because ultimately it is research that drives any science. So there are a lot of problems, open problems that you can address, which are being addressed and which are posing very high challenges for this research scientists, and they are doing really well there. I mean, past 2 years has been a very big breakthrough in terms of say NLP, the natural language processing area, because of introduction of lot of groundbreaking algorithms now. Okay, so new data science institutes. So this was what I was telling you. There are a lot of courses and there are institutes which are being opened and created for the purpose of data science, and there are new degrees as well, right? So that gives you a flavor and idea of how much is the importance this data science is carrying. So ultimately, in a vague way, okay, there is a data, there is need for analyzing this data, which creates some value, which could be used in multiple ways depending on why you are trying to interpret that data. But ultimately, if you try to give some definition or a proper way of saying what data science it is, you can just put it in this way. A data science is an area that manages, manipulates, extracts, interprets. I mean, you have everything here. I mean, you not only directly extract and interpret information, you also have to manage the data, manipulate. You cannot directly use the data in its native way, native form. So you have to manipulate it, then extract certain information out of it and interpret that. Once you have the information, interpreting it and getting value from that interpretation is really important, right? So data science involves all these tasks, roughly saying. So there are many definitions given by many people, but no definition is proper and no definition is right. You cannot say that this is the correct definition. All are correct and all are relevant to the definition of data science. So I've just tried to give you a few definitions. Data science is a multidisciplinary field of study with goal to address the challenges in big data. Somebody says who is very focused on the big data, but though the data is big or small, definitely you have to apply science on it and get to see what value you can extract. So data science principles applies to all data, not only on big data, right? So somebody say that theories and techniques. So data science is a set of theories and techniques from many fields. I mean, it is from multiple disciplinaries, which are used to investigate and analyze a large amount of data. So it is the investigation and analysis of the data is very focus of data science. So for what reason? To help decision makers in industries such as science, engineering, economics, politics, finance, and education, and you can include many other industries as well. Not only industries, I mean, you can just say they are the different the consumers of data. So for them, they have to make certain decisions. So for them to make decisions, they have to interpret this data. That's definitely not possible unless somebody does some processing on that data, right? So when you talk about the different fields and disciplines that are involved in this data science, so you can bring it broadly into these three categories, which is computer science, okay, which is mostly the dominant area of people who are working on data science, okay. But earlier, when you call about data science, mostly statisticians used to work on it and a group of mathematicians. But say that all these three things are very essential. I mean, one is definitely a handicap without the other. Mathematics alone, which gives you the modeling, will not become entire data science, which cannot be interpreted, which cannot be implemented unless you have computer science. And statistics is very essential for many of the interpretation and many of the algorithmic modeling, right? So these three are the very important fields of data science, which somebody should be good at whenever he tries to work or explore data science. Okay, so when you talk about computer science, particularly, it is the different fields of computer science like pattern recognition, which is there for more than 100 years now. So pattern recognition, we have been doing it. There are fancy names now. You can need some called machine learning or artificial intelligence, but though there are differences, but altogether ultimately we try to do pattern recognition only. So visualization, so part of computer science. Data warehousing, so part of computer science again. It's how to manage this data, how to store this data. Okay, high performance computing to handle the big data problem and serve these models and algorithms whenever you want to serve or give the data to these different models, it is not possible if you just have a simple personal computer, right? So it is through a very huge connected set of computers, or you can call it as computing clusters or high performance computing systems or supercomputers in some other sense. So this again one more important field of computer science that is essential. Databases, of course, and artificial intelligence altogether. I just say even pattern recognition, artificial, they overlap in many ways. And mathematics, it is definitely heart of any modeling or anything that you try to do on the data. Okay, so statistics is really important because you do the modeling of some problem, you try to solve some problem on the data. So that's where you bring in the statistics. You just try to see that if you are just doing some aggregation, okay, some distribution matching, see that what are the different properties of the data. Statistics is the one that gives you an overall idea. And many of the optimization, every algorithms, excuse me, so that we use, they rely on statistical concepts. Okay, so I just say these three are the very important fields of study for someone to work in data science. Hope so far is clear to you all. Yeah, this is just a picture to show you how multidisciplinary data science is. So you can just see the different terminologies over there, which are getting overlapped with data science. See, machine learning is to do something with data science. Data mining is there. Knowledge data discovery is there. Okay, databases and data processing is there. Visualization, statistics, AI, neurocomputing, pattern recognition. So all these problems, I mean, all these areas of research and study are really essential for data science. Okay. So for someone to work in the data science domain, these these are the different fields that he should be aware of and he should be very well versed with. Data engineering, so that is where your how do you get the data, how do you store the data, how do you extract the data. I mean, uh, when it is big data problem, so that's data engineering field. And scientific method, different algorithms, math, statistics, advanced computing, visualization tools and techniques. You should have some hacker mindset. Hacker mindset, it is definitely in a positive sense. How do you get the data? You should imagine, you should see something beyond what is visible to you. That's where the hacker mindset comes into picture. And domain expertise is certainly needed. Domain means the the domain of the data, from which domain the data is coming to you. You try to see from that domain and try to interpret. So it's not that you are from a pure computer science background and you are handling some data of some finance. So you do not know what data it is unless you know the finance domain, correct? So you should have certain domain expertise, or you should have someone from that domain experience who is helping you to interpret that data, right? Yeah, so this is the simple examples of real life. As I said, companies learn your secrets, shopping patterns, and preferences. It's very true, and we all know that everything that we use in our mobile phones, the smartphones, or computers is connected to internet. You just use any of the apps, Android apps or iPhone apps. So they are all connected, very well connected to the internet, and those are being monitored, right? Monitored not in a bad way, in a good way. So to give you better experience, to give you the best possible uh, usage of their website or application, correct? So what they try to do is they observe your pattern of using that application over some period of time, and they'll get to know you. It's obvious, right? If you are with someone for say 2 3 years, you'll come to know his hobbies, his likes and dislikes, correct? Where he goes most frequently, which places he likes, correct? Which products he uses. So these are all learned by someone who is staying with somebody for 2 3 years. So in a similar way, if you're using certain application for some time, so definitely when someone sits and looks at your usage of that application, they'll come to know, okay, so if he's purchasing that, then definitely he's interested in it. And uh, that might hint him to recommend you something else which is also equally important for you. When you have purchased product A, product B is also equally important for someone who has product A. So in that sense, they may recommend you the product B. So probably you might not have thought that yes, I would need product B also, but when you see the recommendation, you'll think for a while, oh, is it also needed for me? Then you'll come to make some decision about that. So out of 20 people, if 10 people decides to purchase that product B also, that's an additional advantage for that company, that yes, without his interest of purchasing that, we have sold this item to him. How? Because we have monitored him for his browsing history, for his purchasing history, right? So that's where this example comes. Can we know if a woman is pregnant, even if she doesn't want to know, want us to know? She has not orally said or told that she's pregnant, but the way that she's browsing, the probably the things that she's looking on the maybe the e-commerce site or even on Google itself, will make the backend people who are analyzing her data, uh, they'll understand as definitely the chances is high that she's pregnant. That's the reason why she's looking for these items. These are products which are related to a pregnant woman, correct? So that's how the interpretation comes into picture. But definitely someone cannot sit and look for all people who use the application and do manual processing and manual estimation or manual prediction and manual discovery and interpretation of anybody, because that's huge. If you consider just for example Amazon, you'll see it has billions of customers. Whom do you focus on? Can you think someone can sit in the backend and monitor you continuously for over a year? Can you think of employing someone for this job? How many people do you employ? What knowledge do you think they require? And how long can you think that they can monitor continuously? It's very huge data. There are huge people who are using it. So ultimately what we need, something which can be done automatically without somebody doing it, right? That's where the data science gives you different problems and which can be solved, which are being solved again. So another real life example was the election, US elections during Obama's period. So Obama app, so around 1 million people had installed Obama app. So that gave him access to billions of people who are connected to those 1 million people, right? And then think of what is their likes and dislikes, and think of, and his canvassing in during the elections was very focused. So this is how, I mean, this is the way that you try to analyze without making physical visits and without thinking or without actually knowing somebody, right? So that's really very huge, and definitely there are plenty of problems which are still unanswered. Even maybe there is some problem which um, nobody has anticipated also, nobody has thought of also, so that you can also think of. Or if you are just, I mean, getting into data science, you can think of attempting some of the problems that are being solved by the community of data scientists across globe. And one platform for you, it could be Kaggle, where they continuously post different challenges which are from the data science domain, and you can just take up, I mean, though maybe you are not contributing or you are not competing in it, at least to get the flavor of data, the real data, right? And what challenges it has, you can just try to get into the Kaggle competitions, which are already maybe over and very well solved, and try to see the data, try to see the different approaches people have done. Okay, try to understand in a way. Probably you can definitely attempt. So there comes the role of data scientists, right? So the data scientist, definitely know who is a data scientist. A data scientist is the one who does data science, right? So they find stories. Stories means is this is an area that has a problem, okay, and they build a very strong definition of the problem that is there on the data. They come up with a story on the data, and they try to extract useful knowledge from the data. Okay, they are not reporters. I mean, they do not generate reports from the data. They actually analyze and interpret the data systematically, scientifically, by using many tools and many techniques, and they use a lot of maths and stats to model, and they might also come out with predictions or recommendations, and some kind of analysis as well. So everything is involved as a data science task. It's not only, I mean, specific to only analysis. It could be analysis, then the interpretation, then the visualization. I mean, how do you present the data which can be understood by a new person? I mean, a person from some other domain. How can you make him understand different visualizations that you try to give, which are easy to understand, right? In the form of charts and graphs or different graphical stuff. Okay, and maybe you try to come out with certain prediction things. I mean, you do predictive analytics. So you have data now with you, which is from the historical sense. What you try to do is you try to project it to the future and say that, see, this could be the potential future of this application of or of this domain, uh, by analyzing this past data. Okay, as simple as the weather forecasting. Correct. Simple in the sense that I'm telling you, but weather forecasting is a very challenging job which needs to, I mean, which you have to analyze huge amount of weather data. Okay, so such future forecasting, stock price prediction could be. So these are predictive analytics. It's also a problem of data science. Okay, or you can make some machine do some job for you, as if you are doing. That's also a part of or a field which is having high overlap with data science. Okay, so data scientists are the key to realizing the opportunities presented by data, right? So you have data, unless you have someone who can give you a proper analysis of that data. So what is the use of that data? So they are very key in identifying the different opportunities which are presented by the data. What they do, they bring structure to it. They try to find compelling patterns in it and advise executives on the implications for products, process, and decisions. Okay. So what do they do is they work in many fields wherever you can generate data. Of course, the areas that a data scientist can work are very wide. They are not limited, say unlimited areas which a data scientist can think of, right? Which you can think that as data science is really needed here, ranging from national security, cyber security, business analytics, engineering, what I've been focusing so far is when you call about data science, what is the data that we are talking about, and what are the different source of data that we have, um, I mean, access to, and which we are trying to work on, and what is the different properties of that data, and what challenges that data is posing, and what actually can be done with the data, and what are the different fields which are required to analyze that data and work as a data scientist, and what are the different application areas or the domains that give you this data. So now the focused concepts in data science will be coming from mathematics, applied statistics, and you need solid programming skills in any one of the standard, I mean, the very well used the data science programming stuff like R, Python, Julia, SQL definitely is needed. So you also need a knowledge of data mining and database storage and management and machine learning and discovery. So I would say they are related in many sense, in many ways. Okay, so somebody who is a pure developer cannot do data science directly without learning other parts of the skills and the knowledge related to data science, like at least the mathematics and the statistics, and also the machine learning. So these are all very much essential. Altogether is very much essential for someone to work in data science. So at least one of the programming skills like R and Python is really needed. Okay. So yes, when I talk about, okay, so now we have data, we know what data science is and what all can be done with data science, and why do we need data science, the different application areas and data scientists, their roles. Now, if you focus down to, okay, what is the systematic way or what is the process in which somebody can do data science, right? Though it is not a very standardized one, and maybe some steps in it may not be needed for some data, and there could be some other additional steps which are also essential in some other type of data. But more often, this is a standard process that anyone will follow to work in a data science, means work on a data science problem. Okay, so start from, I mean, it starts from the real world, right? You have the real world data which is collected in its raw form. Okay, you have to find out a way to process this data. So when you call about processing this data, it could be like reading that data properly and modifying the data and its nature, correct? So a lot of such things are needed in data processing. So do you decide whether it is a processed data directly that we have, or it is still a raw data? So you have to do a lot of processing here. If you have done a better processing, then you can definitely do better modeling later. So think of what all processing is needed for this raw data that is collected from the real world, keeping in mind the task or the problem that you're trying to solve. So once this processing is done on the data, you will get a data which is in a processed way, I mean, which you can read and try to interpret. So then what we do is we try to clean that data. Why cleaning is necessary? As I said, the data, one of the properties of data is the veracity, which is noise in it, okay, unwanted information and the bias, misleading information, correct? So you have to avoid that. I mean, you have to filter such biases, noises, enhance your data. So that's where the cleaning process is very much essential. So you clean your data, right? After cleaning the data, you try to understand your data. Understanding in the sense you try to do some exploratory data analysis in this. So by exploratory data analysis, what I mean is you try to understand some of the properties of your data. Okay, how so if this data is a structured one or unstructured one. If it is structured data, then okay, do we have different groups in it, right? Are there multiple groups in the data? Can I study the grouping? Okay, if there are groups, okay, what group has what quantity of data and what type of data inside each, and see the distribution of the data, visualize it, and see how many samples do you have from each of the group, right? And what is the correlation among the different variables in the data, right? Different variables means the different attributes of the data. Do some attribute depend on some other attribute? That's the correlation study that you do. So this simple statistical and visualization related data analysis will give you a lot of understanding of the data that's with you to do further modeling. I mean, probably ultimately the data science job could be most of the times it will not end to the visualization. It will be to the modeling point where you try to come up with a certain value. Maybe could be a classification of your data, could be clustering, or could be prediction, or could be some recommendation, right? So such modeling requires a very clear understanding of the data. So that's where this ADA tasks, generally called as ADA, that is performed to understand the data in your hand. Better you understand, better the understanding about the data, better will be your decision towards selecting the model and uh, do a proper modeling on the data. Okay, so you clean your data, then you do lot of ADA activities ranging from visualization, studying the distribution, studying grouping, okay, studying for abnormalities, right? And thinking of which is essential, what property of this data is very important, right? That's the selection, the feature engineering part. Again, I can tell you. So that's also part of ADA that you do. So these range of tasks will give you a proper understanding, a strong understanding of your data for your modeling. Okay. So now, once you have done many ADAs, then you have understood your data, then you move towards the modeling point. Modeling could be a machine learning problem. Say you may be doing a classification modeling where you're trying to come up with a system which does classification automatically. So that could be one problem you're saying, or it could be a predictive modeling job where you are trying to come out with a prediction algorithm which takes in this data, predicts some variable. Okay, could be as I said, weather or a stock price. You can just relate to many of the problems that is in your mind. Okay, so once you have done this modeling, so this is a very important stuff. So you will communicate and visualize those results of your modeling, and ultimately the decisions could be made, or you can generate a product out of your modeling. So that becomes a data product, so again which is given back to the real world. So here from raw data you have ended up with a product out of this data which gives you some value, maybe a value in terms of money, or value in terms of better service, right? Or value in terms of just study and interpretation. So depending on who is doing this data analysis, right? So I would rather say this modeling and algorithms is very much important, and that's where the focus would later be given, I hope, because as I understood, your next sessions is going to be on mostly on machine learning and deep learning stuff. That's where we talk more about the different types of models, different algorithms that you use to work on the data and create certain systems, maybe for grouping or classification, or for predictions, regressions, or many types of problems and on any data. Okay, so this is a standard process, and probably I just try to touch upon where machine learning comes. So machine learning comes at this point where you try to model and do modeling and algorithms. So machine learning is essential when you try to do modeling and algorithmic modeling. So what does machine learning uh, stand for, or what is it after all, is where you have your data and you know what is expected out of this data. I mean, yes, if I have given some person's photograph, I know who is that person. But what I want to do is I want to come out with a machine which can give me a method or a program, right? Or a model, I can say, which later can be used to do automatic predictions or automatic classifications, right? So it's a, well, let's say, what is the difference between the traditional programming that we've been doing and the machine learning? So traditional programming is you have the data in your hand, right? And you create the program, right? You write the program. So this data and program is given to the computer, and computer just what it does, it executes. What is after all program? It's a instructions. So it executes these instructions on this data, generates the results. So it's merely a computing here, and there is no intelligence this machine is trying to show. Whereas what is required in machine learning is we want to come out with a program, I mean a method which machine can later use to work on the data and generate output. So the program that I want should be decided or arrived by the machine itself by looking at the data and output. The data and the corresponding output. I see, yes, I'll give the machine, yes, this is the data what I have in my hand, and this is what I'm expecting. You try to map this data with this expectation, mapping in the sense, model it, come out with some transformation, some instructions, or some way of converting this data to this output. Okay. What is that? Ultimately, a program. You generate a program, you generate the instructions by yourselves, you generate the model by yourselves from this data to this output. Okay, if I give you this data, this output should be generated by you. How do you do that? You think of it. So that's where the machine tries to learn. So more you have the data with you, which you show the machine along with the output, more it learns. It's as if a kid is learning. You show that, see, this is a tree. You don't explain that, okay, tree means it is having a large trunk and there are branches, there will be leaves in it. Okay, so you just show the kid this is a tree. You also show some other type of tree, you call it as tree as well. Then the kid tries to learn, okay, my father has told both of them are trees. Then it thinks, okay, what is the common thing between those two to call both of them? Probably say a tamarind tree and a coconut tree. Both are trees, but appearance wise, they have a lot of differences. But still, you are able to say that both are trees. What is the uniqueness? What is the commonality between these two to call them as tree only? So that the kid learns. And what is that is differing from these two when compared to say a building? You call something as building, which is building is different from this tree. Okay, that is building and this is tree. How what? So that thinking the machine should do and interpret the data and generate the output that you are expecting. So this is where the mapping is studied, and that is where it is called as modeling in our machine learning terminologies. You call it as model building. So the process of giving data and along with the output for the machine to learn is called as training. Then when the machine is given only the data without the outputs, and when it is asked to generate the output by itself, which should match your expectation that you have, which you have not shown to it, that's where it is the testing part. Okay, so machine learning is to generate the instructions by machine by giving the data and output of the expectations to it. So the different types of algorithms probably will be later studying from machine learning point of view, or broadly categorized into these three. One is supervised learning, where you give the machine different examples of different categories. So supervised learning is where you know that, okay, I have three class of data in my hand, okay, in my problem. Three class means uh, could be as simple as say the problem of tree building and um, say probably I can say person or a pedestrian. So you will give certain examples of trees, certain examples of pedestrians, certain examples of buildings. Okay, and ask the machine to learn what is common in these trees. Okay, and what is common in these buildings and what is common in the pedestrians. And why do you call all these as pedestrians only, all these as trees only, and all these as buildings only? Why? I mean, what is common in each of them? And then, why do you differentiate between a tree and a building? What is different between these two? So that is where the machine has to learn. So you have given the samples of each class that is in your hand. You have given certain examples and asked the machine to learn. So this is supervised. In some other sense, because this is more difficult for you, you have to collect the data. Along with that, you have to label them. Okay, this sample is a tree. This sample is a building, right? So you have to label the data as well in case of supervised learning. That is a little more tedious because if you want a better system, you have to label more examples. So if you want to label more examples, you have to spend more time or you have to employ more people. It's not that very few, like hundreds or tens of samples that are required in this model building perspective. You would need thousands of examples. You would need varying examples. You would need very unique examples also. So collecting data is tougher. Labeling data is more tougher when compared to collecting data. Even if you have data, labeling it is a human job, is a manual job. So what I wish is in some cases, yes, I do have data, but I do not have time to label each of them as like building, tree, or pedestrian. I just give this data, all this data dump to my machine. I want my machine itself to understand, okay, there are three groups in it. Okay, how? Study the samples, look at which are close, which are far, I mean, by their nature, which do carry common properties, which do not carry common properties, and try to think of grouping it. Probably I would say group it into three groups. That is what the best I can do instead of sitting and labeling. I say to the machine, I want three groups here. Sit and study which is the best way to group our data samples into three groups. So it is depending on the perception. I definitely agree because somebody looks it in some other properties way. So I may take the height of each sample. So tree has certain height, building has certain height, pedestrian has certain height. Based on the height that I've seen, okay, some of the trees and buildings get may belong to a single group because those heights are similar. Some of the pedestrian and tree may get grouped into one group because the height of some trees could be very similar to pedestrians type, I mean persons type, human class. So when I don't say that these are the specific classes and these are the samples of each specific class, and I ask the data, I mean machine to do the grouping by itself, then the group that one model or one approach gives you could be entirely different from the grouping that is given by some other model. As true with the humans also. I do not have any knowledge about the data. Only height, some other properties are given to me. I look at the height and I group accordingly. Somebody looks at some other property and groups accordingly. Definitely you have to agree with each of them. Then ultimately you select whatever grouping that you need. So that's again some other type of machine learning problem which is grouped under unsupervised learning, where you do a lot of clustering and dimensionality reduction activities. So there is a problem between these two. So definitely supervised learning is easy for machines, and that's going to be more focused approach, more focused model that is given to your problem because you have given the data labeled and you have asked the machine to learn why these are three different categories because of what properties. Okay, I have told the machine, yes, these sample belong to these different categories only, and you study. So that is way more focused when compared to giving data alone without labels in case of unsupervised. So here, depending on the perception, you'll get the grouping, and depending on how effectively you have extracted the features, you'll get the grouping. Correct. There are a lot of chances of going wrong in case of unsupervised. You may not end up in what you want. So rather, we being humans, we try to be very optimistic, right? Without spending a lot of effort, we try to get more from somebody. So that's where I say that, okay, in that case, what I want to do is rather giving all samples unlabeled, I try to do some samples labeling. Okay, so from each class, out of this 1,000 samples I have, from each class, I try to label, say 10 samples each. Okay, that's the bandwidth that I have now. So I give you 10 labeled samples and remaining 900 or so unlabeled. then you try to build. Okay, so that's again a different approach where it is not completely unsupervised nor not completely supervised. It is a semi-supervised problem. Okay, as you can see here, so these rectangles are all unlabeled, and these uh, red dots and cross marks and stars are all labeled. So I'll give you certain labeled, certain unlabeled. You try to work on the data. Now that's semi-supervised. So your ML algorithm, generally they are grouped under these, one of these, and there's one more category called reinforcement learning, though that's also a possible way. So yeah, probably this will be better when you'll get clear idea of the entire machine learning system model when you try focusing on the machine learning concepts later. But to give it a very brief and very high level focus onto it, I just say you will have a problem which is a modeling problem which requires machine learning. Okay, you do some data pre-processing there, you do some normalization, you do feature selection. Ultimately, you try to convert the data which has come from the real world problem. You try to convert that data into a structured representation, okay, which we call it as a feature matrix or data matrix later. So that, depending on whether the data is associated with the labels or not, means you have the data, whether each sample in your data is labeled or not, that decides which way to be used for the further modeling. If it is unlabeled, you will go with grouping the data, right, by machine itself. So that's where your clustering comes into picture. Then cluster the data. Think of each clusters as your labeled data now. Work out with a classification, that is the supervised model. You train your model, right? Then train your model means you give your data along with the labels of each samples and ask the machine to learn the dependency or the mapping between the samples and their labels. And you try to test your model. Test in the case, in the sense that you give the data now, means again the samples, but you don't give the labels to them. You ask the machine to predict those labels. If it is a classification, predict the class labels: tree, pedestrian, building. Predict for each of the text sample that you give. Then check out if you have obtained satisfying results. I mean, whether the labels generated by the machine are up to the mark, are okay for you. If that is okay, then definitely you can go back to the real world by your solution, or that can again be repeated with different way. Means you would rather see different features or you would apply different normalization, right? You would either select different classification model, or you may do the training on a different data set or a different training set. See, you have connection back to each of these steps. So you can come back to any step from any step when you see there is something wrong with the current step. See, if testing has gone wrong, you may come back to training and do better training. Or even where you feel that, okay, what, even after doing a lot of training also my test results are not okay, then you can come back to selection of a different classifier, correct? Or you may ultimately come back to the clustering, or you may go back to the features itself, correct? So this is a cycle, but with many loops inside, right? I hope this will be put very nicely in upcoming sessions for you when different ML algorithms are dealt. Okay. So I just wanted to say machine learning is a very important part of the overall data science, because apart from machine learning, other parts of other steps in the data science are more well defined, right? But you have to ultimately have some domain sense and experience to work with even those steps as well. But machine learning is a very critical step where you have thousands of algorithms. You should study and understand them and decide which algorithm is suitable for what type of data, correct, what type of problem in hand. So that requires a lot of understanding and experience. So this is a very important step in data science. So yeah, so I have tried giving you an overview of how the data science problem is approached. Then I just want to give you some of the applications of data science, ranging from different domains. But though these are all not the only ones, you could think of many other fields which have data science applications. So, but these are the very important and booming or hot areas which are carrying, I mean, definitely a lot of money and research and complexity in it. See, healthcare. So it's a, though rather than calling it as a problem with um, um, finance related thing, it is something to give back to the society where you can enhance a lot of healthcare activities by doing data science. See, from medical image analysis, you might have now seen there are a lot of applications that healthcare sector is using, ranging from automatic analysis of say X-ray, CT scan, PET scan images for disease-specific anticipation. I mean, the analysis. So they are used as recommender systems now. I mean, the doctor is recommended, or it is a supplementary tool for doctors most of the times. So which gives some secondary opinion to the doctor himself by looking at the images or the samples. So drug discovery. So earlier drug discovery used to take lots of effort and time, but now with the help of data science, drug discovery has the time taken by the people uh, who are working in drug discovery area has been reduced to lot. And bioinformatics, virtual assistants. So in healthcare, if you look at the transport sector, so you might be amazed with the concept of self-driving cars. See, definitely self-driving car is really an innovation of the century, because self-driving is very tough. I mean, you just imagine the different activities that you do when you drive a car. Your all sensory organs are up and working, and they are in better sync. Your legs are in better sync with your hands, and your eyes, your brain, correct, your ears. So when you hear something from the backside, you automatically do some other actions without even seeing it. So they are very well working. They are coordinating to each other, syncing up. So if you think of automating that, see, you got vision, that is through computer vision activities. You got signal processing, the audio processing maybe. So that's again a different thing, correct? You might have to read some signboards, signals in front of you. You might have to detect the different objects in front of you, correct? That you do seamlessly without taking much time in real time. But when you think of some system which has to be embedded in a car, it's not something supercomputer which is given to you along with your car. It has to be a very smallest device that's capable of doing all these, right? You cannot employ a supercomputer inside a car, or you cannot think of having a supercomputer inside a car. You cannot afford to that car as well in that case. So with less capability, more actions, ranging from computer vision, text detection, understanding. So I'm just trying to map it, right? Classification, even the noise, signal processing, right? And many mechanical activities. So carries a lot of stuff, and all of them should work in sync, in better coordination, in real time. So that's why self-driving car is a very tough problem. And data is coming from multiple modalities. It is coming from the images, I mean the vision, or it could be coming from the audio, or it could be a text data, or it could be so even the scene could be captured in multiple sensors. So you could use your normal cameras, could be lidars, could be radar signals. So there's a lot of stuff involved, lot of data to be processed in such cases. So there's a huge challenge and opportunities in transport sector as well. So finance, there are a lot of applications. There are a lot of banks and financial organizations which are leveraging these technologies, the data science technologies, to handle their data, to make their products better, to give better experience to the customer, to reduce their cost, or to uh, make better benefit. Okay, so that's about fintechs or manufacturing fields. There are a lot of manufacturing units, I mean, which used to have a lot of manual processing that's being automated now. And e-commerce, definitely you know the recommendation systems on the e-commerce sites are really good examples of how data science is being leveraged in e-commerce, right? So again, it's a different landscape of application. So if I just go on giving you the idea of the range of applications and the different areas that data science is being explored, so I definitely would need this to give you the example. So the list just goes on and on. Okay, so just go along with me in looking at these slides. They are self-explanatory um, to you. Retail and e-commerce, fintech. So I've just listed down what are the different automations, the different the areas are different problems that are being solved in fintechs using data science, machine learning. Okay. So whether and coming to the companies, so you now see, I mean, the very big brands, or you can say the huge uh, tech giants, which are Google or Apple, Microsoft, Amazon, Facebook, Intel, Twitter, right? They are all dominant in data science and AI. Okay, so the big companies means they are doing definitely a lot of AI and data science and machine learning. Okay, so when compared to any other company, so this gives you an idea of how um, important this field has become. And this figure also shows you the different startups these companies have acquired over time. That gives you a sense of the importance of doing data science. So these are the some of the references. Okay, yes, I totally accept that most of the content on these slides are not from me. They are collected and aggregated for this particular purpose. So I would rather ask you to visit these sources if you want those individual stuff. And definitely, I think I have given you the overview of data science, ranging from the data to its applications, right? And the process, different tasks involved. I hope um, it was uh, it served the purpose of this session. So I definitely would like to discuss if you have any of your clarity or any questions that is in your mind. So we'd take another 5 minutes or so to discuss on that. Thank you.
So thank you, sir. It's a really very nice talk on introduction to data sciences. I think everybody understand the basics of the data sciences clearly through your presentation and the wide applications you given, so that they got a good idea about the data science basics and applications of the data sciences. Now the participants raise your can raise the hand and can select the hand symbol if you want to ask any questions. Morning session, somebody left because of his busy schedule. We stopped today.
Here that is Dr. Samiran Banik and Kalpana Saha.
Yeah,
Both
yeah,
raised their hands. They can come. They can come forward. Please,
yeah.
Samiran
So,
Banik.
sir, Samir, sir, you can ask. Morning time, you raised a hand, but due to the busy schedule,
Yes.
stop. Yeah,
Hello,
yeah,
sir.
sir.
Hello, sir. I'm Samir. I'm from the Central University of Kerala only, and I'm basically a life scientist who work on functional genomics. Most of my work involves analysis of data that comes out of the transcriptome analysis, the RNA analysis, the small RNA analysis, and these are huge amount of data that comes in. So, as of now, we are taking help from our bioinformatics friends to get the things done. But I wanted to know, like, how easy would it be for a person from the life science background, like I'm coming from, to get used to the algorithms and the patterns that we have to learn to find a specific pattern if I want to find it from my whole transcriptome data. Like, is it that the algorithms that we have to use, that we have to write, would be very difficult, or it's like that's what I would
Yeah,
comments on.
yeah. Yeah, thank you, and it was a really a nice question. So, it definitely data science, as you have seen, that it is not going to be a computer science based field alone. It is a field. It has gained importance only because of the different fields or different areas that are posing challenges which can be solved from data science, right? So, people from the biosciences, or people maybe from the chemical sciences, or from the health sector. So you got a lot of problems, you got a lot of data even, but you may be struggling with the right direction or the right approach to solve it. So because like generally, as we accept that you are the domain experts here,
Yeah.
and you have to possess the problem. So I would rather say, instead of working independently,
Yeah.
do some interdisciplinary work. I mean, that definitely helps you. I mean, it is not that you independently cannot work and solve the problem. You cannot learn data science, which is required for your problem, and do. But rather, it would be really good if you get collaborated with someone who is from the data science domain, okay, and try to pose your problem and get worked with it.
Yes, sir.
So
That's a really
yes,
nice idea. That's what we do. Usually we collaborate. But the thing is,
correct.
when we have to collaborate with a pure data scientist, we also should be having a minimum knowledge of what exactly in
Right.
their language I should tell them that I want.
Right. I understand.
Yeah.
So this is where, I mean, you need not to study. You need not have to study the statistics. You need not have to study the mathematics of it. But you, at least if you study, okay, what data science covers, what are the range of problems, and if you get to know the philosophical way of the problems, and the philosophical idea behind each of the data science approach, not with the technical perspective, at least from the philosophical perspective, what it is, then you'll be gaining a lot of idea on it. You can pose it, okay, so it is one of the classification problem, or it is a pattern matching problem. You have to find a subsequence in this given sequence, right? So we generally call it as, okay, the problem that you posed, so it is a DNA matching problem. You got a lot of a huge DNA sequence of something, and you are looking for some particular pattern in it. So it is a pattern matching problem. You got a string of data, and you have a substring which you need to match. So you can just pose it, and you probably can look at the similar works. Okay, so one way that I tell you is, look at the similar works from the bioinformatics field, and how they have approached the problem, and how they have converted this bioinformatics problem into a data science problem. So because data science, you have a specific categories of problem. So your problem will definitely fall into one of these categories. So the right way is try to identify what is the right category of a data science approach for my problem. Then try to understand that category from the philosophical point of view, rather than getting into deeper. Then probably you will get a lot of tools for that particular approach. Maybe, or you can get support from someone who is working in data science. So that way of collaboration is the way forward for you.
Thank you. Thanks. That helps.
Thank you.
Madam, who is that next one? Next one name? Hello. Taslima madam.
Sir, Samiran Danik.
Amita. Yes.
And Kalpana Shah also there.
Hello, ma'am.
Yeah, please.
Yes, madam. We can hear you.
Kalpana Saha from Kolkata, West Bengal. I have one question, sir. What is the difference between data scientist and data analysts?
Yes, really an interesting question. There's a lot of debate on people who do what and what should be called for each of them. When I see the I call it as entire data pipeline. So who are working on the data basically. So the different group of people who work on the data is the core technology team, who maintain the data, uh, take the data, read it, and manage it, and give you in a easily accessible form. They are data engineers. They don't do any kind of analysis on the data. They don't do any interpretation on the data. They just, their task is to rely on the hardware platforms, different integration platforms. Like if it is a big data problem, they may have very strong knowledge on Hadoop ecosystems, how to use distributed computing to gather the data and give it in chunks maybe later for you to process. So they are data engineers. Okay. Then next comes the data analyst job. So data analyst, they are not very focused onto the technology side. They mostly rely on the tools, like the visualization tools. Okay, you probably might have heard of some of the visualization tools like ClickView, right? Or uh, some simple dashboarding tools. Okay, so what they do is they get this data from data engineers. They try to present the data to you, for the data scientists, in a way that data scientist can interpret it later, when where he can apply. So data analyst's job is more into using tools and taking data from the data engineer, using those tools and coming out with certain useful visualizations, more or so, or some simple analysis on the data, like applying some simple statistics. Okay, so there is the role of data analyst that ends. And someone who does the modeling stuff, actual modeling, interpretation, exploration of the data, so all these will be a part of data scientist. Okay, so there is a very narrow difference, or I mean, this is overlapping roles. So data engineer might also do data analysis job through his experience, or his interest, or a data analyst might also be a data scientist. Okay, so with the experience, these roles can go further, and the ultimate role is the data scientist role. But in industry, most of the times data analysts turn to be data scientists later, through their experience and the knowledge that they gain, or through the proper learning that they do. But strictly speaking, data analyst's job is it ends up to data analysis only. They do not do modeling and final ultimate model training and whatever task that we do in machine learning again, probably.
Okay, next.
Hope that helps.
Thank you, sir.
Next, Samiran. Samiran, please unmute. Samiran, are you there? Yeah.
Sir, we can call Professor S. Babu.
Professor S. Babu, morning also he raised the hand. Sir, Professor S. Babu, please unmute and ask the question.
Hello.
Yes, sir. Yes, yes.
Hello, sir. We can hear you.
Sir, I'm from Bhubaneswar, Odisha. Basically, last 10 years, I'm into business analytics. So,
Right.
what are the tools I can apply for the graphical and you can say voice data to numerical processing and as well as the textual processing?
Okay, so you say you need to understand the different tools.
Yeah.
For the business analytics. Generally, your data is in the text form.
Text as well as the numerical form, but sometimes I get the data in the graphical form.
Okay, so don't say much about the graphical data. So, but if you have the text data that is with you, generally, so for the textual data, we use some of the tools like Spacey for doing a lot of textual analytics. Okay, so depending on the task that you want to do.
Now, basically what happens, I get the data like in the case, I mean, suppose you are designing the data into a graphical mode like a Tableau, through Tableau.
Right.
Okay.
Right.
So when you will receive those kind of graphical data, I mean, the visualize the data. So how again you can convert it into the numerical or textual data?
As long as I understand, correct me if I'm wrong. So you get the data first, then you project it onto the tool like Tableau for your visualization, right? So generally there's a data. For example, you have just gathered the transactional data, and that the Tableau tool captures and gives you with visualizations like graphs, charts, different charts and graphs. So I think you have the data from Tableau, that the visualization from Tableau. Definitely you will also have the underlying raw data with you, which is already in numerical form, I guess.
No. Sometimes what happens, I got the project in a Tableau format. So how I again retransport to the textual or the numerical data?
I think this is, I mean, even I'm not aware. So if you get the Tableau data, I understand, as long as I have used the Tableau tool, the Tableau data will be given to you along with your native data. So if you have the native data, then only the Tableau tool displays that data. Or maybe
No,
you
that
have
is correct.
you just have saved the Tableau output into some pictures.
That is what, if the Tableau output I have, then how again I can convert into this textual and numerical data?
I doubt that is possible. If you have only the
Oh,
visualization, going back to the raw data is highly difficult. I mean, assume that you got a bar chart, which gives you the frequency, probably histogram of some data. Then
that is
nobody
a
can
line
go
chart
back
or the
to,
column chart.
yeah, nobody can go back from the line chart back to the raw data. So that's definitely is, I mean,
Yes,
impossible.
Not possible.
yes, sir.
Okay.
Yes, sir. It's right. Visualization is the end of the
And
representation, knowledge
going
representation.
back requires data. I mean, if you have just saved those images, going back is definitely different.
So you will not come
Okay.
back backwards. Okay.
Okay. Thank you
Okay.
very
Thank you.
much.
Thank
Thank
you.
you.
Thank you.
Yeah.
Next, Umar Farooq. Umar Farooq, please unmute.
Hello, sir. Am I audible to you?
Is the
Yes,
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 yes.
Umar, you're audible.
Thank you, sir, for your valuable and informative presentation on data sciences.
Thank you so much.
Sir, I'm currently working on a research topic, content-based cybercrime detection, wherein
Okay.
that contains cyberbullying, abusing, or spreading the sexual
Yeah,
content
yeah.
and other things. So I know that I have to perform multiple feature extraction, feature selection techniques, and machine learning models. But sir, I'm just confused about do I have to, when I collect the data from multiple social media platforms, uh, so do I have to perform the labeling manually or go for the clustering? So I want you to suggest
Uh,
me what would be the best option.
okay. Yeah, yeah. First of all, I really congratulate you for taking such a good problem, which is having some social cause in it. When you talk about this abuse detection or bullying on social medias or social networks, one challenge is gathering data. So, hope there are some standard data sets that are available that you can leverage. Okay, abuse detection. I mean, they are classified into two classes, either, whether it's abusive text or normal text. So you can just try to leverage them. Uh, so if you are collecting from by yourselves, then probably are you labeling it, or are you approaching it as a clustering problem? That's the question I have.
Sir, actually, I'm from Kashmir, so I have to perform this cyberbullying detection in the Jammu and Kashmir area. So I have to collect the data from the multiple platforms regarding the Jammu and Kashmir area.
Okay, so I have been successful in it. I mean, collecting your region-specific data, I doubt that is possible. I mean, that level of fine graining is given by standard data sets or any social media for that matter. So I doubt they've given the region-specific. At least I think it's country-specific data you might be able to get, but region-specific, I doubt if it is possible. I do not have idea about whether that data is available or not. But as long as your problem is there, and if you have data, approaching
Sir.
it requires like a lot of feature analysis. So definitely you can approach it in multiple ways.
Sir.
So do a statistical text processing, so like the standard bag of words based approach, or you would think of some deep learning based approach as well. So where deep learning based approach is like you work on the uh, summarization, text summarization problems, or you try to work on the entity recognition, right? So you can approach such, or even you can just think of the sentiment analysis as one of the solutions to them. Okay.
Thank you, sir. Thank you, sir.
Yeah.
Yes, next.
Hello. Good afternoon, sir. This is
Good afternoon.
Shri. I'm from MNIT Bhopal. I want to know that what are the use cases of big data and data science?
Okay, so I mean, so whatever that we talked on, the different applications that I showed to you, they're all the use cases of big data and data science in general. But some of the applications may not involve big data. Yeah. So when you say big data, generally, I mean, as a field of study, big data refers to data that requires distributed computing. Maybe like you use Hadoop, Spark to consume this data and manage this data. So that's from the technology point of view. From your modeling and data science point of view, whatever the data it is, whether it is a big data or normal data, so you can just explore data science on that. See, I'll tell you how it works is if it is data which is like there on your normal computer, then you do not need any big data tools like Hadoop or Spark. Okay, you can just work on your personal computer, get the data loaded onto your memory, and use your data science related tools, like you may be working in Python or R, right? So you can just approach the problem directly. But if it is a big data problem where you got the data not only present on your computer, but it is present on heterogeneous systems. I mean, multiple systems are on a cluster, maybe like it is there on the cloud. Okay, so it may be there on AWS cloud, or it may be there on the Azure cloud, or it could be there on your private cloud as well. So if it is a cloud data, then mostly if it is AWS cloud, definitely you have a lot of ways, which are, I mean, the managed services given by AWS that you can just leverage to use that data and work on the data science problem. But ultimately, when you speak about the use cases, big data use cases, instead of calling it as big data use cases, you can call it as just generally data science use cases. But when it is data, could be big data or your normal data. All the applications.
Well, okay, sir. Thank you.
Next, anybody is there? Any questions? Kalpana?
Definitely, if I mean, they can reach out to me, sir. You can share
Yeah,
them
sir.
my
Yes, sir.
details. They can
Please
reach out. I'll
contact
be
them.
very
Sir,
more than happy to discuss.
Sir Kumar, sir, can I?
Yes, sir. Mallikarjunappa, sir, please.
Yeah. Sir, I am from the Department of Commerce, Mallikarjunappa Central University.
Nice, sir. Thank you.
Yeah, we have some data in the PDF form. I'll tell you even what is the data that we are trying to analyze. These
Yeah.
are the mutual fund holdings in different companies. You know, we
Right.
have about
Yeah.
50 asset management companies, and each of them will have about 50 schemes, and then they will have about hundreds of companies holdings. But
Correct.
they give this data in the PDF form. It is not available in the text form or Excel form.
Right.
How do we put that into Excel form? Or if it is available in text form, we can. PDF or say Excel form it is. But in the PDF form, we are not simply able to use manual feeding the only option, or you have any other software tools that can help us?
Yes, sir. Yes, sir. So first of all, I would like to know whether that PDF, I mean, can you select the text on the PDF and paste it onto some word processing software like Microsoft Word?
Yeah, that is, we can copy and then paste it, but
Okay.
that is highly
Yeah.
time-consuming process.
Like I understand, sir. So just wanted to know, because like when you speak on PDF, there are two ways of having
Yeah.
PDF. One is like you have
Yeah,
scanned
yeah,
the
correct.
document, a physical document, and obtain the PDF. That is more challenging when compared to a
Yeah.
system generated PDF. That what you told. So your
Yeah.
use case is more or less complicated compared to scanned PDF documents. So
Okay.
here, the simplest tool, I mean, you can just go with simple Python based. You will get simple Python code that you can run to convert those PDFs into text, okay, or even
Okay.
into Excel. But the challenge is if you have tables in it. For
Yeah, it is
example,
stable. It is stable.
okay, it is, if it is tables, generally when you use simple approach to read that PDF and convert into text, generally that the table structure is lost to some extent.
Oh, okay.
So yeah, that is again depending on how difficult or how complex the table is. If there are simple tables without like you mean like I'm saying about tables with like rows spanning multiple columns or columns spanning multiple rows. So such complex tables. In that case, the
Yeah,
chances of losing
it is
information like
actually. You have
columns.
multiple columns,
Correct.
multiple rows.
Yeah, columns, multiple columns spanning a single row. For example, there is
No,
one heading.
no.
There's
Okay.
one column heading which has two subcolumns inside. So in such cases, generally this the data will be structure is not so good when you convert that. But otherwise, you will have very simplest tools that you can use. Or I can just name some of the Python-based. You will get online PDF to text converters. That, I mean, sometimes they are limited to the number of pages. But open source wise, you can use some Python script in.
So PDF to text converters, what is happening? It will not take it as numerical data. It will simply take it as some type of any other word or something. We want that to be a numerical data which is available for computations, further computations.
Okay, you mean it's not coming to be a numerical one? It is treated as the text
Yeah.
only.
Yeah.
Yes.
Yeah.
Okay. Yeah. In that case, you can just use this Python scripts that's available. Probably I will share you offline, sir. Any of the scripts that I find useful
Oh.
for you.
Okay.
You can
Yeah.
just send out an email to my ID.
Okay.
I'll try to gather some of the useful tools for you, and I'll share you.
Okay. Fine.
Yeah.
I think that's about the queries. If anybody is there, thank you, sir. So,
Sir,
yes.
sir, this is Hariharan, sir.
Okay.
Yes, sir.
Yeah. You
Can I ask only one question?
Yeah.
Yes, sir. Please go ahead.
Sir, I have been attending data sciences conferences and everything. I feel it is my opinion, actually, my own opinion, actually. Data scientists and other people who are learning data sciences are giving very less importance to interpretation, sir. Means in projects and we do the students projects and all, if we do collect data and analyze and interpret it, we give some findings and we give some decisions and suggestions. Is it really happening in data sciences, or from the role of data scientist, actually, whether the data scientist is collecting data and analyzing and interpreting and giving the exact results which where the decision should be made?
So coming to that,
Do
I
you
would
think
rather
the
say
question
it
is
is more.
clear?
Yeah. I understood. I would rather say it's more subjective and problem-specific task, whether you need um, the findings to be given in a correct, like the interpretable form.
Okay.
So more or so, what happens? The data science applications.
Okay.
So you might end up with having application which has certain problem that is posed.
Okay,
It is
sir.
not always you have data and there's something which you do not know that problems are extra. There is some
Okay.
specific requirement that is driven. Say for example, I have huge e-commerce data with me. I want
Okay.
to study customers' behavior, and based
Okay.
on that, I want to recommend such products to certain customer.
Okay.
Just for example, So in this case, I do not need to come out with some interpretation of the data. Instead, I just have to come out with a tool based on my data science. So which can give you, like, for example, I just pose a customer's profile and his browsing history of over last 1 year on my e-commerce site.
Okay.
What I want from the tool is give me back some products as output, which can be recommended in some specific ranking. So I want some product A to Z to be given back for that person in ranked order, so that I can just display on my site whenever he comes and logs in. I can just show him, okay, so this product may be of interest to you.
Okay.
I cannot randomly show some product to him. I should systematically study his browsing history, his way of purchasing on my site, then only give. So that is the problem driven. In some other sense, what you said was it is not problem driven. It is I just want to generate some value out of the data. Correct.
Okay. Means
You
in the
might
sense,
have a
in the parallelly we can do some findings programming also. For example, what
Sure,
are all the things the tools is ordered to do. Means as you said, it is ordered to do some interpretation. What I am asking is, I need some findings also, so that the further research can be made to by using the
Certainly.
findings.
So the limitation or the difference is whenever somebody does this data science job
Okay,
in
sir.
industries, they'll have very less scope for reporting these findings and doing
Oh,
some research on
okay, sir.
top of
Okay,
that,
sir. Okay,
unless
sir.
it is a research lab.
Okay, sir.
If it is a
As
R&D,
an okay, as an academician,
definitely.
I was really
Yeah,
interested to do
as an
this.
academician, definitely. As an academic data scientist, you will definitely look for something which can be a research problem later for someone. So you just
Is there any tool? No,
give
isn't
your
it? Is there any tool, sir, for reporting the findings and all? No, not like that. Isn't it? Is there any tool?
I doubt. I mean, I don't think there is a need for this for any tool to report findings. Instead, you have to come out with a properly drafted research article and get it. I
Oh,
mean,
oh, oh, oh. Okay, sir.
read
Okay,
by
sir.
the peer researchers and academicians, so that they can
Thank you, sir.
understand. Okay, this is somewhere I can do that.
Thank you, sir. Thank you so much,
Thank
sir.
you.
Thank you, sir.
Thank you. Hope, sir. I mean, I've
Yes, sir.
done my
That's
best, and
yeah.
definitely will be more than happy to catch up later, even with the different queries or discussions that they have. They're really interesting to me as well.
Yes, sir. They are very really interesting to ask doubts.
Yes.
Participants, please collect the contact details from the resource persons if you wish to contact in future also. So we have a time
Sure, sir.
limit, so that we have to wind up the session. So, sir, it is really very nice session on introduction to data sciences,
Thank you,
and
sir.
questions regarding the questions participants asked, and your explanation is also very nice. And on behalf of the Department of Computer Science, our heartfelt thank you, sir, for accepting our invitation and delivering a good session. I think sir will come tomorrow also, so that we'll meet tomorrow, sir.
Yeah,
Afternoon
I'll try
session.
to
Yeah,
see some demonstrations
yeah,
and
yes.
tools.
Second session we will
Yes.
meet.
Sure, sir.
That's only. If anything is there, with anybody, or else we'll wind up the session, today's session.
Yes,
Thank you
sir.
all.
We can wind up today.
Yeah, sir.
Suhail, thank you so much.
Yeah,
Thank
Thank
you.
you so
Thank you.
much, madam, and thanks for all the organizers for giving this opportunity. We'll
yeah.
definitely meet tomorrow. I'm more excited now. Thank you.
Yeah, sure,
Yes,
definitely.
sir. Yes, sir. Thank you. Thank you.
Yes. Okay,
So,
then. Bye.
okay, sir. Okay. We'll wind up the session. All of you join